In the last class, so we have discussed the projections of planes, means basic concepts related to projections of planes like definition of plane and different types of planes and various positions of planes. So in this session, so we will discuss types of problems in projections of planes. So already we have discussed, so plane is a two-dimensional surface having length and breadth, so with a negligible thickness. So we have different plane surfaces. So plane surface with straight edges, so plane surface with curved surface and plane surface with irregular periphery. Now we will discuss types of problems in projections of planes. First one, lamina resting on HP with one of its edge or side. Next, lamina resting on HP with one of its corner. Lamina resting on VP with one of its edge or side. Lamina resting on VP on one of its corner. So in the problem, so before solving the problem, first we note down the type of the lamina. So what kind of lamina is given in the problem? So whether the lamina is triangle or square lamina or pentagonal lamina or hexagonal lamina or circular lamina or rectangular lamina. So first note down the type of the lamina. Next, check whether the lamina resting on horizontal plane or vertical plane. Check whether the lamina resting on horizontal plane or vertical plane. Suppose if the lamina resting on horizontal plane, okay, here assume that this square lamina is horizontal plane. Suppose if the lamina resting on HP, if the lamina resting on horizontal plane, then start the first position with the top view. Next, suppose if the lamina resting on vertical plane or VP, then start the first position with the front view. First note down the type of the lamina, whether it may be triangle, rectangle, square, pentagon, hexagon or circular lamina. Second one, check whether lamina resting on horizontal plane or vertical plane. Suppose if the lamina resting on HP, start the first position with the top view. If the lamina resting on VP, start the first position with the front view. Next, assume that the lamina resting on horizontal plane. Okay, assume that the square lamina as horizontal plane. Assume that the lamina resting on HP. Now, check whether lamina resting on HP, whether one of its corner or side. Okay, here, in this position, the given lamina is triangle lamina. The triangular lamina resting on horizontal plane with one of its side. With one of its side. Okay, here, the lamina resting on HP. So with one of its side, the side resting on HP. Now, okay, here in this position, the lamina resting on HP with one of its corner. The lamina resting on HP with one of its corner. Suppose if the lamina resting on VP on one of its side, assume this wall as vertical plane. Okay, here the lamina resting on VP with one of its side means this is the resting side on VP. The lamina resting on VP on one of its side. Suppose corner resting. Okay, here this is the corner resting. The lamina resting on VP with one of its corner. The lamina resting on VP with one of its corner. Okay, here this one is lamina resting on VP with one of its side. When the lamina resting on VP, start the first position with the front view. When the lamina resting on HP, start the first position with the top view. Now, let us discuss the first one. Lamina resting on HP with one of its side. Okay, here this position is indicated by, I have taken triangular lamina. Triangular lamina resting on HP with one of its side. Now, first draw XY line. Next, indicate VP HP. So all problems solved in projections of plane are first angle projection. Means first quadrant. All problems are, so the resting condition in projection of plane is first quadrant. So therefore it is indicated by VPHP. First draw XY line, then VPHP, first angle projection. Now the condition is lamina resting on horizontal plane with one of its side. So in the projection of plane, so we made one assumption. The resting condition is considered in case of projection of plane is left side. We can also take the resting side towards right side. Just to avoid confusion, okay, here I am taking the resting condition towards left side. That means, okay, here this is the resting side. Okay, here the lamina resting on HP with one of its side. Okay, here the resting side comes towards left side. Suppose if the lamina resting on HP with one of its corner means the resting corner should come towards left side. So in the projections of planes, the resting side is left side, just for our convenience. So we can also take the right side as resting condition. Okay, here I am taking left side as resting condition. Now, lamina resting on HP with one of its edge. Now, how to draw the top view and front view? Say, take the triangular lamina. Lamina resting on HP with one of its side. So observe here, the resting side comes towards left side. Now the lamina resting on HP with one of its side. Now the lamina is completely resting on horizontal plane. The lamina completely resting on horizontal plane. Now, so what is the top view? If you look from the top of the object, it is a triangle shape. If you look from the front of the object, okay, here this triangle lamina appears as a straight line. Now, how to write the top view and front view? Which view should I write first? First I should write top view. Since the lamina resting on HP, this is horizontal plane. The top view is triangle. Okay, here when you look the object from the top, okay, here I will going to see the triangle shape. Now, so draw resting side towards left side. Now draw triangle lamina. Draw triangle lamina. Then do the naming. Corner A, B and C. Then indicate the dimension. Say let it be 25 mm. So let it be 25 mm. So this is the top view. So I am looking the object from the top. Okay, here I will going to see the triangle lamina. I am writing the resting side. AC is the resting side. AC, it should be on left side. Left side is the resting side. Next step. So draw projection lines. Upward. Projection lines means thin lines. Draw projection lines. Projection line means thin lines. Projection lines means the lines which connects the top view and front view. Means the lines which connect the views. Projection lines. Now, okay, here the front view is the straight line. So this is the front view of the triangle lamina. This is the front view of the triangle lamina. Now, naming. So when you look the object from the front, point A visible, B visible, C invisible. This is point C. Therefore, front view is indicated by A dash, C dash and B dash. So front view is a straight line. So this is all about triangular lamina. Similarly, square lamina. Take a square lamina. Square lamina resting on HP. Square lamina resting on horizontal plane. Resting on horizontal plane with one of its side. This is the resting side. Okay, here the left side is considered as resting side. Therefore, towards your left side, draw square lamina. Okay, here draw square lamina. This is the resting side. Now draw the top view. Okay, here when you look from the top of the object, okay, here we're going to see a square shape. This is the top view. So now do the naming. ABCD 4 corners. Next indicate the dimension. Draw extension line. let it be 25 mm. I have completed the top view. Next, how to write the front view? To write the front view, draw projections, draw upward projections up to XY line. Draw upward projections up to XY line. Now, when you look from the front of the object, you are the observer. So you are looking this square from the front. Okay, here this square looks like a straight line. I cannot able to see the complete view in the front. I can able to see the square shape in the top, but in the front I can able to see only a line. That means the front view of square lamina is a straight line. So therefore, okay, here, so this is this straight line. The gap between the two projection line represents the front view. Now, so this is the direction of view. So when you look from the front of the object, A visible. So A visible, invisible corners are indicated in the bracket. Now, okay, here B visible. Behind A we have point D, D invisible. Behind B we have point C, C invisible. This is the representation of square lamina when it is resting on HP on one of its edge. Similarly, take pentagonal lamina. Take pentagonal lamina. Pentagonal lamina resting on HP with one of its side. Say example, assume this square lamina as horizontal plane. Now, the pentagonal lamina resting on HP on one of its side, the resting side. Now, when you look from the top, we can see the pentagonal shape. When you look from the front, the pentagonal lamina appears as a straight line. So therefore, so draw a resting side towards your left side. Now complete the pentagonal lamina. Complete the pentagonal lamina. Pentagonal lamina consists of 5 corners. Therefore, do the naming A, B, C, D, E. Then indicate the dimension. Draw extension line. So let it be 25. So I have completed the top view. When you look from the front of the object, the pentagonal lamina looks like a straight line. So therefore, draw projection lines means thin lines from all the corners, from all 5 corners. Now, the gap between projection line represents the front view. Now, okay, here, this is A dash, so this is B dash, and this is C dash. All 3 points are visible in the front view. The invisible corners are indicated in the bracket. Okay, here behind A we have point E, it is invisible, E dash. Behind B we have point D, it is invisible, D dash. So this is the front view and top view of pentagonal lamina. Now similarly, hexagonal lamina. Hexagonal lamina, so resting on HP with one of its side. So construct hexagonal lamina taking resting side towards your left side. The side towards your left side represents the resting condition. Okay, here I have constructed a pentagonal hexagonal lamina. Suppose if you construct a hexagonal lamina like this, so this is wrong. As per this condition, this is wrong because in the problem he has given the lamina resting on HP. Okay, here the lamina resting on HP. The lamina resting on HP, this is HP zone. This is also HP zone. Okay, here the lamina resting on HP. But lamina resting on HP with one of its side. Okay, here. So this is left side. In the left side we have side resting condition or edge resting condition, but in the left side here we have corner resting condition. So therefore, so this is the wrong diagram as per the given condition. left side condition is the resting condition. Now draw, do the naming A, B, C, D, E, F. 6 corners are there in case of hexagonal lamina. Then indicate the dimension. Let it be 25 mm. Now draw vertical upward projections to get the front view. So front view is a straight line. Front view is a straight line. Okay, here A, B, C visible. A dash, B dash, C dash visible. Behind point A we have F invisible. Behind point B we have E invisible. And behind C we have D invisible. So this is the first condition, lamina resting on HP with one of its edge. Similarly, lamina resting on HP with one of its corner. So okay, here corner resting condition. So this is HP. Now lamina resting on HP with one of its corner. Therefore towards your left side, construct laminas such that the corner should come on left side. Say triangular lamina. So triangular lamina, okay, here construct a triangular lamina. Construct a triangle lamina A, B, C. Indicate the dimension 25 mm. Now observe here, towards left side I have a corner. Observe here, towards left side I have a side. Therefore here the lamina resting on HP with one of its side. In this diagram the lamina resting on HP with one of its corner. This lamina resting on HP with one of its corner. Right. So this is the top view. Since the lamina resting on HP, I should start the drawing with the top view. Now to get the front view, draw upward projections. Draw upward projections from all the corners. So the gap between these two lines represents the front view. The front view is a straight line. Now this is A dash, B visible and C invisible because C is behind of point B. Similarly, square lamina. Square lamina, take corner condition. Take corner condition A, B, C, D. Out of 4 corners, which one is the resting corner? Point A, point B, point C or point D? Point A is the resting corner because point A is towards left side. Therefore, point A is considered as resting corner. Now, we can indicate the dimension. Indicate the dimension, so let it be 25. Now, I have completed the top view. To get the front view, draw upward projections from all 4 corners. Now, which corners are visible in the front view? Okay, here, this is the direction of view. A visible, B visible, C visible. Therefore, the views must be dark. So, A dash, B visible, D invisible and C dash. Similarly, pentagonal lamina, corner condition. So, construct pentagonal lamina. Point A, B, C, D, E and indicate the dimension 25. Point A is the resting corner. Now draw upward projections. Draw upward projections. So this is the front view. A dash, B visible, C visible, E invisible and D invisible. Next, hexagonal lamina. Lamina resting on HP with one of its corner. A, B, C, D, E, F. Indicate the dimension on any one of these side. Let it be 25 mm. Out of 6 corners, which one is the resting corner? The corner towards left side is considered as resting corner. Now to get the front view, draw upward projections. To get the front view, draw upward projections. The gap between the projection lines, the extreme two projection lines represent the front view. A dash, B dash, C dash, D dash, in bracket F dash, in bracket E dash. So these are the basic conditions. When the lamina resting on HP with one of its side, start the first position with the top view and construct the resting side towards left side. Observe here, AC is the resting side, AD is the resting side, AE is the resting side, AF is the resting side. Point A is resting corner. Okay, here also, in all condition, point A is the resting corner. The corner which is on left side. The side which is on left side is considered as resting corner. You can also take the corner or side towards right side. Next, lamina resting on VP with one of its edge. Say example, take square lamina. The square lamina resting on VP, assume this wall as vertical plane. The square lamina resting on VP with one of its side. Now, in which view I can able to see the front, means a true shape. In the front view, okay, here I can able to see the square shape, and in the top view the lamina looks like a straight line. Therefore, start the first position with the front view. Why should I start the first position with the front view in case of lamina resting on VP? Because when the lamina resting on VP, okay, here in the front view, so you are the observer. You are observing the square lamina in the front view. When you observe the lamina from the front, I can able to see the complete view. This is the true shape. Now, when you observe the lamina from the top, so when you observe the lamina from the top, okay, here the lamina looks like a straight line, right? Therefore, always start the drawing with the true shape. So, true shape comes on the vertical plane. Therefore, first start the drawing from the vertical plane. Now, take triangle lamina. The lamina resting on VP with one of its corner. Now, it is represented by like this. Why it can't be like this? Suppose if you draw the triangle lamina like this, observe here, the corner comes towards left side. Corner comes towards left side. But in the condition he has given, lamina resting on VP with one of its edge. Therefore, edge should come towards left side. Edge should come towards left side. Okay, here, in case of lamina resting on VP with one of its corner, okay, here, this diagram is correct. But in case of lamina resting on VP with one of its edge means you are supposed to draw resting side towards left side, right? Then indicate the dimension. So let it be 25. Then complete the drawing. The true shape, okay, here lamina resting on VP. Therefore, I can able to see the triangle shape in the front view. Therefore, draw triangle shape in the vertical plane. Front view, it is denoted by A dash, not ABCD. ABCD notations are used for top view. A dash, B dash, C dash notations are used for front view. A dash, B dash and C dash. I have completed the front view. Now, when you look the lamina from the top, the lamina appears as a straight line. Now, to get the top view, so draw thin line, very thin line up to XY line, means downward projections. Draw downward projection from all the corners. Okay, here these lines are called as projection lines. Right. Now, the gap between these two lines represents the top view. So, views must be dark. Now, naming. In the top view, this is the direction of view. In the top view, Which corners are visible? C visible, B visible, but A invisible. Invisible corners are indicated in the bracket. So this completes the front view and top view of triangle lamina. Similarly, square lamina. So square lamina resting on HP, square lamina resting on VP with one of its side. So it is represented by like this. So draw square lamina of 25 mm side. You can indicate the dimension. So let it be 25. Then complete the square lamina. Since front view, in the front view I can able to see the true shape. Next I have completed the front view. In the top view, which corners are visible? Okay, here I am observing the square lamina. In the top view, D visible, C visible, A invisible, B invisible. To get the top view, draw downward projections up to XY line. Draw downward projections up to XY line. The gap between these two projection lines represents the front view. So this is the front view. Views must be dark. Now D visible, in the top view D visible, and in the top view C visible. Next, in the bracket, A invisible and B invisible. Similarly, pentagonal lamina, lamina resting on VP with one of its side. Construct pentagonal lamina with side resting condition. Okay, here this is the pentagonal lamina with one of its side. Okay, here left side we have a resting side. So it is indicate the naming, indicate the dimension, then do the naming. A dash, B dash, C dash, D dash and E dash. Now draw downward projections from all the corners to get the top view. So this is the top view. In the top view, E visible, D visible, C visible. E visible, D visible, C visible. In the bracket, A invisible, B invisible. Next, hexagonal lamina. Hexagonal lamina resting on VP. This is VP region. Hexagonal lamina resting on VP with one of its side. Construct hexagonal lamina with side resting. Now indicate the dimension. Indicate the dimension and do the naming. A dash, B dash, C dash, D dash, E dash and F dash, and draw projection lines to get the top view. Draw projection lines to get the top view. In the top view, F, E, D. So F visible, E visible, D visible. Next, A invisible, B invisible, C invisible. Okay, here all these diagrams represents the resting condition of lamina on VP with one of its side. Okay, observe here. I have started the drawing which is the front view because lamina resting on VP. Next, I have started the drawing by considering the edge towards left side. Observe in the all diagram, in the left side we have resting sides. In this diagram, AC is the resting side or resting edge. AD is the resting edge, AE is the resting edge and AF is the resting edge. Next, lamina resting on VP with one of its corner. Lamina resting on VP with one of its corner. How to draw the front view and top view for this condition? Already we have discussed. Lamina resting on VP with one of its edge. Here lamina resting on VP with one of its corner. Corner should come towards right side or left side? Left side, because left side is considered as resting condition. Therefore, for in case of triangle lamina, observe here, in the left side we have a resting corner. It is indicated by, first indicate the dimension 25 mm. It is A dash, B dash and C dash, right? Next, to get the top view, draw downward projections, means projection lines from all the corners. The gap between these two lines represents the top view A and C and B. Similarly, for square lamina, lamina resting on VP with one of its corner, construct a square lamina considering resting corner towards your left side. How to construct? Construct a square lamina. This is A dash, B dash, C dash and D dash. 4 corners are there. Now you can indicate the dimension 25 mm. Next, draw projection from all 4 corners to get the top view. A visible, D visible, B invisible and C visible. Similarly, in case of pentagonal lamina, construct a pentagonal lamina. A dash, B dash, C dash, D dash and E dash, taking corner towards left side, that is resting corner. Now draw projection lines from all 4 corners. So okay, here top view A, E, B, D and C. And at last we have a hexagonal lamina. Hexagonal lamina A dash, B dash, C dash, D dash, E dash and F dash. This is the front view, resting corner A. Now to get the top view, draw projection from all the corners. Right? Now A, F and B, E and C and D. Now in all the diagrams, we understood that when lamina resting on HP, we should start the drawing with the top view. When the lamina resting on VP, we should start the drawing with the front view. Next, when the lamina resting on HP with one of its edge, take resting edge towards left side. When lamina resting on HP with one of its corner, take resting corner towards left side. Here when lamina resting on VP with one of its edge, take resting side towards left side. When lamina resting on VP with one of its corner, take resting corner towards left side. Next one, with locus problems means beta angle and alpha angle problems, and without locus problems means no beta angle and alpha angle problems. So when we need beta angle and when we need alpha angle. So already we have discussed in projections of lines, beta angle and alpha angles are apparent inclinations. Angle theta and phi are true inclinations. So when do we need apparent inclinations? Means when do we need beta angle and alpha angle? So let us discuss. So that is with locus problems, means beta angle and alpha angle problems. See in case of triangle lamina, median is present. Next in case of square lamina, okay, here diagonal is present. Next in case of pentagonal lamina, okay, here we have perpendicular bisector. So in case of triangle lamina, so we have a median. In case of square lamina, we have diagonal. In case of pentagonal lamina, we have perpendicular bisector. In case of external lamina, we have a diagonal. And in case of circular lamina, we have a diameter. Now in the problem, suppose, okay, here in case of with locus problem, appear word is not there. Appear word is not there. Remember, so in case of with locus problem, appear word is not there. So let us consider one example. Say in case of problem, if the median inclined to VP, if the median inclined to VP, or if the diagonal inclined to VP, or if the perpendicular bisector inclined to VP, then we need beta angle. So when do we need beta angle? When the median, perpendicular bisector or diagonal or diameter inclined to VP, then we need beta angle. Then when do we need alpha angle? When the median or perpendicular bisector or diagonal or diameter inclined to HP, then we need alpha angle. Right? Okay, here. So we need beta angle when median, diagonal, perpendicular bisector, diameter directly inclined to VP, then we need beta angle. So when the median, perpendicular bisector, diameter or diagonal inclined to HP, then we need alpha angle. Next, without locus problem means, okay, here in this case we do not require apparent inclinations. So in this kind of problem, appear word is there. Suppose in the problem we have the word appears to be inclined. Suppose in the problem we have the word appear, then we do not require any beta angle or alpha angle. So when do we need beta angle? Sorry, so okay, here when beta angle is not required means when the median or diagonal or perpendicular bisector diameter appears to be inclined to VP, then beta angle is not required. Suppose if appear word is not there, if the appear word is not there, then beta angle is required. So this is the condition. When appear word is not there, then we need beta angle. When appear word is there, then beta angle is not required. Similarly, when the alpha angle, when the median, diagonal or perpendicular bisector or diameter inclined to HP appears to be inclined to HP, then alpha angle is not needed. Suppose if appear word is not there, then alpha angle is required. When the median or diameter or perpendicular bisector inclined to HP, then alpha angle is required. So this is the condition, alpha angle. But here appears to be inclined to HP means alpha angle is not required. Right? So therefore, with locus problems and without locus problems, so we can conclude that when the median, diagonal or perpendicular bisector or diameter, so when all these conditions, when the median or diagonal perpendicular bisector diameter inclined to VP, then beta angle needed. When median, diagonal perpendicular bisector diameter inclined to HP, then alpha angle needed. Next, when median, diagonal perpendicular bisector diameter appears to be inclined to VP, then beta angle not required. When median, diagonal perpendicular bisector diameter appears to be inclined to HP, then alpha angle is not needed. So these are all the different kinds of problems in projections of planes.